Hello everyone, welcome to my workbench. As you can see, I've assembled almost all of the 3D printed parts together. It's pretty big. I didn't expect it to be this large. It's nearly 1 meter in length, quite big. There are still some small parts scattered around that I'll take care of later. For now, I need to install the electronics inside. I designed the model with removable covers on this side to provide enough room to work. Due to the varying build volumes of 3D printers, I divided the model into several sections. Each section has locators to assist with positioning. Simply print these cubes and insert them into the designated places. You can apply super glue or use a solder iron to secure the parts in place and ensure alignment. In this area, there are various support pillars needed, each with different dimensions. It's important to place them accurately in their designated positions to ensure structural stability. One of the most exciting aspects of this project, in my opinion, is the electronic component. I aim to make this device function similarly to how it appears in the video game. At the very least, it will simulate firing, display the ammo count, and feature a compass. In the video game, the compass indicates the mission location, but in this project, it will provide dynamic effects to enhance its visual appeal. Alright, let's proceed with calibrating the electronic component. In this project, I have noticed that assault rifle features a switch capable of toggling between at least 3 modes. Based on the markings, I presume the bottom one corresponds to the lock or safe mode, where the firearm is unable to shoot when switched on. The middle setting appears to be the single shot mode. If my assumption is correct, it means you can only fire 1 bullet at a time by pressing the trigger. Finally, the top setting seems to represent burst mode. In this mode, you should be able to shoot continuously by holding down the trigger. Let's assume my interpretation is correct. I've incorporated a 10K potentiometer into the device. Considering the switch has 3 modes, I've designed the component accordingly. When you turn the switch, you will feel it clicking into place, similar to a ceiling fan switch. Once it reaches the desired mode, the switch will hold the potentiometer in place, ensuring it obtains a specific value. Open the Arduino IDE and load this file. Before uploading the program, ensure that the wiring is correctly connected. This program will assist you in obtaining the appropriate potentiometer value. Once the program is uploaded, open the serial monitor. You will observe a series of numbers displayed. When you adjust the potentiometer, you will notice the numbers changing in the serial monitor accordingly. These numbers represent the readings from the potentiometer. Begin by setting the potentiometer to 0 value. Now take these 4 3D printed parts, insert the switch into the designated hole and mount the seat on the other side. You can use super glue or solder iron to securely attach the parts. Place the moving contact at the bottom. And use 3 M3 screws to secure the cover in place. Now turn the switch to feel its movement. Applying a bit of grease can enhance its smoothness. Take the potentiometer and set it to 0 value. If you haven't done so already, carefully insert it into the switch. Then adjust the potentiometer to 25. Use hot glue to secure the potentiometer in place. Once the hot glue has cooled, turn the switch to the middle position, and you should see the value read 31. Turn the switch to the top position, and the value should be 37. If you have different values, there's no need to worry. have set a tolerance, so if your values fall within the range, everything should function properly. Perform a few more tests and monitor the values. If they are all correct, it indicates that you have successfully completed assembling this device. I'm using a 1.9-inch LCD for this project, which is likely the largest size that can fit into the model. Unfortunately, this LCD cannot display the full picture as shown in the video game, because the one in the video game is not rectangular. It's in a specific shape. To assemble this part, you will need 6 pieces of M2.5 screws, 2 round magnets with a diameter of 10 and thickness of 1.8, and the 3D printed parts. The display is attached to the PCB, and you will need to detach it for it to fit it properly. Use a blade to gently slice between the display and the PCB, carefully wiggle it, and cut through any glue holding it in place. Once the display is separated, attach it to the bracket. Also mount the PCB onto the bracket. Lastly, take the housing and assemble all facing parts with the screws as shown. Take the LCD and bracket, gently push the bracket into the housing and ensure it fits properly. Take the other half of the housing and align it before pushing it into place. Secure it with screws. You can choose to insert the magnets at this step or do it later. I'm using an ESP32 development board, which is powerful enough to process both pictures and sounds simultaneously. Double-check all connections to ensure you don't risk damaging your control board. To get the program working, you'll need to install a few Arduino libraries first. The first one is the TFT SPI, which will enable the LCD to work. The second one is XT-DAC audio, which processes the audio. The last one is MPU 6050 Lite, which you can find it in Arduino. This library provides a 3-axis gyroscope and offers dynamic effects for the compass. I'll put links for all the libraries so you can download and install them. I came across a pair of speakers that were lying around, and they are powered over USB. I believe I could incorporate them into this project. Previously, I was using an LM386 audio amplifier, so if you are planning to start this project, feel free to use any audio amplifier you have available. Before I proceed with placing all the electronics inside, I need to install some pillars first. These pillars serve not only as support but also reinforcement for the structure. I have previously marked the lengths accordingly. Since these pillars vary in length, I have chosen to use a specific type of tool for each. However, you could use any type that you find suitable, as long as they are of M3 size. I've intentionally left out 2 pillars, which I will fit later. Now I believe I'm ready to move forward, but before I do, let me paint it first. Now all the models have been painted, it's time to bring them all together. The assembly is straightforward, requiring only super glue. Get the ESP32 control board and secure it with 2 screws in place. To attach the trigger switch, simply screw it into the designated hole and test by pressing the trigger to ensure the switch can be activated successfully. Before installing the magazine switch, insert these 2 3D printed springs into the designated holes in the chamber. Then attach the switch and ensure it will be activated when the magazine is inserted. Ensure the magazine moves smoothly when pushed in or pulled out of the chamber, and apply grease if necessary. Get all wires organized and contact a test to ensure both magazine and trigger function properly. The bullet quantity should reset to 36 when the magazine is inserted. It seems that everything is functioning as expected. Now I'm going to put all the covers on and it will be finished.
Cortana.
Hello, John. It's good to see you.
Fine.
Hide and seek's over.
Alright, that's all about this project. Please comment if you have any questions about this project. If you enjoy the video, please give it a thumbs up and like. Share the video with your friends and family, and considering subscribing to my channel if you are interested in 3D printing and electronics. I'm Tony, and I'll see you in the next video.